Hello. Good afternoon, everyone. Welcome and thank you by attending this session. My name is Jorge Maia. I'm CEO of Crazy Tech Labs. We are a company that we are working with IoT since last 3 years. Today, our agenda is a meetup. I don't know if everyone here knows what is a meetup. It's not a regular session that I will present and just have a question and answers. But I believe on the idea of the meetup that we can share experiences here about the real world of IoT. Not just the blinking LED or using some platform or just connected to a cloud. No, just not just this. But let's talk about what the real world is doing. What's the cases about the Internet of Things and what this is going on and what we have the challenge for the future. So I will try to do my best to not extend the slides, and we can share this experience of everyone. Feel free to take the microphone, and I give it to you anytime to talk about your experience or what were you doing and to help everyone here in this session. So just to begin, what is IoT? So the term is coined in 1999. A lot of people are talking about the new revolution, the new era of technology, but it's only to connect things without human interaction. That is what the Kevin Ashton says in 1999 when he put some IoT devices using RFID to identify some stuff connected to the internet. So that's the main idea behind the Internet of Things. I like to talk, when I talk about Internet of Things, that we have to put intelligence on that. Intelligence that maybe not stay on the hardware, not stay on the device, not stay on the microprocessor, but stay now on the cloud. And we have a lot of tools today to do the intelligence on the cloud. When we talk about Internet of Things, we are talking about connect anything. Like a fridge, we had a meetup today on this room talking about connecting fridges and take humidity and take the temperature, take the cans inside it, and how the technology they use it is a very, very good one. We have today a lot of cell phones on the world, a lot of cell phones and more cell phones than people on the world, and it can be seen as a Internet of Things device. We have cameras, we have computers, but we have more stuff. We have now cars connected, we have animals, we have humans, we have elevators, we have a lot of things. We have tools connected, and this stuff is generating data. And on the data is the first thing we have intelligence on that. And I believe when we talk now about Internet of Things, a lot of guys address the term to hardware. When we start talking, let's talk about Internet of Things, let's talk about connect things, okay, it's Raspberry Pi, it's Arduino, what microprocessor we will use, let's talk about LoRa, let's talk about Sigfox, but this is the smallest portion maybe. On several solutions, this may be the smallest portion. Because when you talk, I take two cases that my company participates last year, and on both of them, the hardware was the smallest part. Our work was in the cloud, our work was sending data, our work and our challenge and our threats was security on communication, security on data, how we will store data, and that was the biggest portion of the project. And another thing is for makers, and when I say makers is the generation that we see now, that takes a Raspberry Pi and put inside the home and turn your own home intelligent. This is makers. That's the guy that take an Arduino, for example, and create a 3D printer. That's a maker. That do by yourself. So it's interesting. It's good. Sometimes it is the beginning of the new technologies, but for makers, IoT is pretty new. It's brand new. It's the new technology. It's the future. It's the revolution. But for the industry, we can see since the 60s decade, pipeline connected and sending data and analyzing data. Oh, we didn't have cloud. We didn't have a Power BI, for example, to do some dashboards. Oh, easiest, much easiest than we had some years ago. But they did. That's the question. So it's not new. When we take a heart sensor or something like this, we have a lot of this small pieces of hardware connected a long time ago. When we talk about health, we talk about hospitals, connected stuff 10, 20 years ago. So it's not so new. But we have now a new revolution that we can use that easiest than ever to connect and take this data and transform this data in intelligent stuff. That's the magic on Internet of Things in my point of view. So just to start the discussion, some of the new real world that the people is talking about industry, for example. We are talking about the industry 4.0, the new industry. So now everything is connected. No, a lot of time everything is connected. Now we can connect the pipeline to a smart city, to a guy inside a shop, to a sales representative. So now we are connecting what was connected to the internet to another things. And that's the new revolution. So this will be the biggest one. It's not, I'm not talking about that, and that's not my phrase. The specialists, the analysts of the market are saying that. So this, I believe, is the real thing that we have to see, that we look forward. The new revolution is not to connect things, not to wire some sensors in a small board. And how can we use this data, and how can we analyze this data and unify this data with another one? That's the challenge. That's the big data. That's the idea of take a sensor here and put with data on the social network and put it all together to take a new dashboard or a control of, for example, this whole building. Control this whole building, for example, we didn't have the bottlenecks that we have on the escalators. We have a lot of. So there's a problem. And we can't measure that? Yeah, we can. We can take, for example, a camera and count people. It's not so quite complex. And it can be addressed as an Internet of Things device. So this is the idea when we talk about the new revolution. Not just, we have a lot of platforms on Kickstarter. Yeah, we have. That's the good thing. Oh, it's becoming cheaper. And the new idea is that on 2020, we have a microprocessor with some connectivity on that by $80. So that's the idea. We have it today. We have some MediaTek processor with $10 today that you can put on production. So it's good. It's not so expensive to do a device. It's a good one. And this is what we have to say. No, don't look only to the hardware. Don't look only to the small portion of look to the cloud. Look to what we can do on the cloud with this data. Look to machine learning. How can I learn patterns on that data to use and to combine it to another thing to transform lives. That's what we need. We have some predictions that we don't have food in 30 years ahead. What we can do? The field is the same. We have to do more production, but we can't do more production. We already have a lot of stuff on that, a lot of technology on that. The precision technology is already on the farms. But what we have to do? Use the intelligence to produce more. So I believe that's the new mainstream when we talk. When we talk about healthcare, we are talking about a market, $117 billion by 2020. That's good. That's the idea. That's the idea when you talk about Internet of Things. When you talk about agriculture and smart farms, today's the local farms and the large farms can use IoT to remotely monitor sensors, can detect soil moisture. It's real. It's not it's a huge technology, it's so expensive. No, it's not. It's cheaper. It's cheaper. Oh, I want to control my irrigation equipment. Okay, no problem. You can do it today. But what's the difference? You control this, but if you use a weather API plus a sensor plus satellite images plus a lot of things and detect patterns on that and use it to control your irrigation equipment, you are becoming better. I believe that is the idea. Not only connect, not only hardware, not only you have. I was talking. I talk in a lot of universities and meetups in Brazil, and we use it to say that today you have a lot of stuff that you install an app on the phone. So, I have a bulb. I put a bulb on my home, and I install an app. No, I have a fridge. I install an app. I have something else. I install an app. It's good. But how many apps you have? Now I want to sleep. No, a bulb do not talk with another one that do not talk with the, and we are seeing that today for some house experience becoming hubs to, I have a bulb, it's connected to the thermostat, it's connected to the door, and when I open the door, when I becoming home, my GPS send a message, a note, and said, I'm home. Oh, okay, good. That decreased the temperature. Let's turn off the lights. Let's turn on the lights. And I believe that's the real feature. But what is this? Data on the cloud. That's the main idea. When we talk about tracking and monitoring, how many kids are kidnapped or lost every day? Oh, a lot. How much costs a sensor to find them? So cheaper. So this is the idea. The devices will become cheaper day by day. What matters? The data, the intelligence behind them. What do we have when we talk about IoT solutions? When we talk about IoT solutions, we have some like this, and we have flavors that we can use. You can do it by yourself. I can now use some solutions, a bunch of solutions in Azure for IoT. For example, if I have an IP device, I can connect it directly to the IoT hub, for example, and then to stream analytics and send my data to a NoSQL database or to a DocumentDB. And then, I want to have a Power BI connected to a relational data, so I save twice the data. No problem, you can do it. It's easy. Or you can use the IoT suite that we pre-factoried a lot of services together, and we can one-click install, and it's working. So we have a predictive system. I have some graphics here to show you. It's interesting, yeah, it's good, and it's accessible. It's servicey. And why we didn't use? When we talk about Internet of Things, the guys know, I will install my own broker, I will install my MQTT broker in a VM. You will pay more to do this. No, it's only a prototype. It's only a POC. No problem. We will pay more. Why are you doing this? So you have the total infrastructure today to do this. So why you not use it? When you go to Azure, it's just one click to install IoT Hub, event hubs to process some message to another systems and to your legacy systems, for example, that you can use. Stream analytics, machine learning. Machine learning is 2 or 3 clicks to set up an environment. Oh, it's easy to use it. It's more or less, because you have to know the rules. And when we talk about machine learning, there is sometimes that you take physicians, that you take statistics, that you take chemistrians. So a lot of guys behind the rules to comprehend the data and to generate some intelligence on that. So that's what we have today. For example that I talked before, Azure IoT Suite. What do you have to do to set up an environment like this? Just maybe 3 clicks. You set up a remote monitoring, for example. Then you have the control of your devices, you have the control of your users, you have the control of your portals, you have maps, you have addressing the devices to your maps. You have a lot of stuff here working together to give you what matters, the dashboard. The final information concentrated in one place, just one place. That's what you need to start your real world, to become more professional. And I like to talk more a little bit to decrease your time to market. So your time to market become less than if you should use all the technologies and put all together and do it by yourself. Here is, for example, I take this from the website of Microsoft, a dashboard of a sample device. Oh, I have to create my own device? No. You can prototype it over here. You can create a C# simulator or a Node.js simulator, because what matters for you? The whole data that is becoming from the sensor. That is the idea. That's what you need. So let's give the data. Just give the data, connect it to the hub, or connect it to your MQTT, or connect it to your proxy. You choose your gateway. You choose what you want to do. And here you have of course, this is a simple demonstration of some data. This is real. Yeah, it can be real, but you have more and more work behind the scenes, because you have to analyze it. This is beautiful to show, to see what's going on, but let's take some decisions. It's not here. Of course, you will not take a panels and stay looking at it all day long. It's not real. So that's the idea. Let's talk a little bit about, I take two or three cases here and 2 cases that our company works on. The first one is this that I like so much to talk about that case, because it takes my idea of real life. Every senior, and everybody knows that seniors forget to take the medicine. And there is another problem. They change the medicine. My parents sometimes do this. So, oh, you have to take these medicines at 3 p.m. Okay, I will do it. And when well, what's happened? I take it, 3 p.m. No, but you take another one. How many you take another one? Oh, 7 a day. No, you can't do this. And this can be a problem. Imagine the senior that forgets to take the medicine. When you will know? Sometimes when the disaster already comes. So this is a problem. This company, the Proteus, have an intelligent system that There is a microchip on the size of a grain of sand inside the pill. When you take the pill and it goes to stomach, it sends a message to this path that is on the body of the patient. It sends a Bluetooth alert to the cell phone, and it connects to the internet. Oh, it's not real. Yes, it's real. FDA approved and working. But it doesn't matter. Yeah, it matters a lot. Because you can connect the senior with the doctor. But to know if the senior takes the medicine, no, not just this. Imagine another scenario when you have the real idea that the senior takes the medicine and feel the vital signs from another sensors. For example, a smartwatch like this, or a Microsoft band. You have a lot of sensors. You know what's happening. And you can send them a message and say, oh, I need your blood pressure now. Oh, send an ambulance to catch them. That's the idea. That's the idea when you talk about Internet of Things, is to change the life of another people. That's something that you can use to produce intelligence. But now it's very, very good. No, it's still difficult to use because you have to put a patch on the body. You have to have a cell phone near here. So it's not so easy as I talked before on the marketing talk. But it's the beginning. It's the beginning, a new era. It's the beginning, a changing to connect people. When we have a diabetic disease, for example, you have some tattoos that you can put to see the sugar in the body. It's new. So we are growing to this kind of wearable devices. It's interesting, but it's generating what? Data to connect to your medical historic, and you can do a lot of stuff with this. Another one is a pet tracker, for example. How many pets you see lost on the streets, and how many childs inside home becomes crazy. Not only childs. If my dog runs out of my home, I will become crazy. But it's interesting, maybe, but it's cheaper. For a pet owner, it costs less than 100. And you have an annual plan that you pay $10 or $15 by use the GSM card on that. So you have to know where your dog is. Yeah, only this? No. You can measure the activity of your dog. You can know where is it, how long it takes without eating something. So this is the idea. The idea is not monitoring only the position, and monitoring a lot of stuff, a lot of data that you can take it and analyze after. Let me take a video here. This video of ThyssenKrupp is interesting. This is a video about the HoloLens, but I wish you look at that thinking how they want to use the HoloLens, because they use the HoloLens just to see the stuff on the field engineering, on the camp, on the buildings. But the ThyssenKrupp, before this project, start an IoT project to monitor every elevator and escalator that it has. So imagine a company like this, the biggest one that it is, working and predicting systems, thinking, oh, I have to do the maintenance on that building. How much it put on money back doing this. I believe this is the idea of when we talk about real world.
Over 1 billion people ride elevators each day, which places the industry in a primary role to respond to the challenges of urbanization. ThyssenKrupp's mission is to drive the elevator industry norm. We want to do better and want to really push the envelope for what we are doing.
We need to enable our people to use the latest technology possible and available, and HoloLens is such a device where we see potential to serve our customers better.
The introduction of HoloLens to our operations will empower the over 20,000 field service engineers in doing the job better, more efficient. Increasing availability of elevators and escalators makes the job more safe and more fun for our people as well.
The scenario we have developed is really about dispatching a service technician using HoloLens in very different kind of ways.
So as soon as the technician puts on his HoloLens, he already sees, I have a call here, I need to go to this elevator, and then actually sees a 3D picture of the elevator that he's going to work on, and that he can zoom into a part that will offer you also training opportunities.
He goes to the job site prepared, probably better prepared than ever before, because he has the relevant data available to him in the best format possible, and in a variety of ways he can tailor the data towards his need.
The technician putting on his HoloLens, looking at the elevator, sees the historical notes first, so what has actually happened with this elevator before. He already has all the information right there without having to look for it. It saves a lot of time and a lot of stress and effort.
He gets information on his virtual desktop about the task orders he has to carry out,
The latest safety alerts for that elevator.
He pulls on a 3D replication of that part, pulls it out in an exploded view, and can actually see which part is making the problem.
A major advantage of the HoloLens, of course, is that we are hands-free, and we never had that experience and the capability before.
In the past, the technician needed both of his hands to operate the laptop, and now he just has his HoloLens on.
One of the most important capabilities we see with HoloLens is that we can trigger a remote call to a subject matter expert.
Call Heather.
Hey Jeff, how you doing?
I'm replacing a doorboard out here, but I kind of want you to check a couple things out.
Okay, let me take a look. Your JP3 is in the right position and your motor leads are disconnected, so you're good to go.
It takes a lot of stress out, it saves a lot of time, and our field tests have shown that there's a huge potential to increase productivity with that. The job, which normally takes 1 to 2 hours and maybe ends up with having the expert traveling to the site, we were able to carry it out on the first time in less than 20 minutes. What we are
This video, this idea of the guy of the maintenance goes to an elevator and change the parts defective is nothing without they know what is going on this elevator. So he goes to the building with the parts because they have a lot of sensors on it. It's not an isolated case. You have a lot of cases like this on the world nowadays. It's real cases about the using Internet of Things. If you go to the industrial, if you go to smart farms, you have a lot of this predictive systems talking and doing the companies to put the money that they spend on the fields to do more research or to do another stuff. Just come back here. Let me talk about two cases that we worked on last year. The first one is the for parking. This is a good one to talk. We started working on this project. They maybe on the beginning of the 2016, they want to measure if there is a car on the place. So the parking lot, there is a meter in Brazil, and they want to know if there is cars in the lot. Oh, you can use cameras, you can use a lot of things, you can use a bunch of sensors, but there is a problem. If you put some sand inside the sensor, for example, and the sensor doesn't know that, maybe you were meeting that this is a car, and it's not. And the idea was to put some sensors in every place to know there is a car over me or not. And we start on the project. They have a lot of people working on that. And our job was, what's the correct thing to connect it to the internet? What you can use? You use a old protocol. You can use a new one. It will go to the cloud, where it will go, and how. That was our job on that. So this is the last version. I can't explain deeper about the hardware, and I can't explain deeper about a lot of solutions that they use, but we can talk about a little bit about. This is the first one that we worked in since last 6 months ago. This is a good one because the only thing that we have here is maybe a heartbeat. So I'm live, I'm not, I'm occupied, I'm not. That's it. But we have a lot. When we talk about a parking lot, we are not talking about a parking lot, a privacy parking lot. We are talking a public one. We are talking about a city. We are talking about 15, 16,000 devices in a neighborhood. So that's the challenge. When we talk about Internet of Things and we talk about send data to the cloud, we are talking sometimes about thousands and thousands and thousands of devices sending second by second something. How can we use cheaper communication and reliable communication? That was the first case that we worked. The second one was a ride-share application called Hey, that the main idea of everything that you sell us as a service is my client, my customer, my user is satisfied. When you use Uber, for example, when you finish a ride on Uber, you receive a message that says, oh, how many stars you give to the driver? And why? Why you give only 4 stars and not 5? Oh, the route or maybe the car, the smell of car. What's the problem? Why you didn't use 5 stars? And we start thinking about a lot of things. The first one, the driver doesn't a good driver. Another one, too loud inside the car. Temperature. That's the most things that the people talk about when about Uber and taxi and this kind of applications. We talk about, the driver is not good, the car smells not good, too loud, they talk a lot. The driver was talking, and it's boring, the travel is not. And we start not thinking only about the passenger. Our idea was, if we listen to the passenger, we can listen just one. And this is not a good day for him. Hey, I don't know, broke up the Romans. No, everything on that day will be bad for him. That's the idea. So if you ask, oh, how about the ride? Bad. Because his feeling's bad. But it's not real. And we have to measure that. And what's the best way to measure that? We think to put a hardware inside the car to collect some data about the car, like route, like the real velocity and acceleration of the car, and a lot of stuff. After that, we have a lot of data to talk about. Then we start our first challenge, a lot of models. We can't connect the same connector for CAN, that is a protocol to take data from the car. You can't connect to the whole bunch of brands in the market. If you have to do some adaptations on that. And this was a big challenge for us. And after that, we had the information that the user sends to us. We collect some data from APIs. For example, the weather APIs. We take the weather API, we take the velocity of the car, we take the response of other passengers, we put it all together and says, oh, everybody that takes a ride and it passes through that way or that path, we have bad news from the users. That was the first thing that we hear when we start using the machine learning and put it all together and connect all this stuff on that. So this I prepared for, we start our discussion, and I want to open to questions, if you have any questions about what I told, or to say what you are doing or in what project you want to talk your experience. It's open. Let me take the microphone. Okay. Nobody? No? It's always the same on meetups.
You mentioned pushing all the analytics up to simple computations, maybe on the edge.
We try to
Power, for example, voltage and amps, but really only want power. Mm-hmm. That type of scenario.
Yeah, we tried in one project to do it on the edge. On that one, we have restrictions by the power. We have power restrictions because we need to use for example, on that case on the for parking, we have to use the battery on that. That's our main idea on that. If we put anything else on the device to process on that, we have to use power. And we have to increase the costs because the microprocessor should be higher and we have more memory, we have needs more, and that's the problem. If I have the raw data, I create dumb devices, and the dumb devices, I can put it to sleep and to wake up to send it data.
What about cleaning up maybe noisy signals from a sensor, so using like a weighted average on the edge as opposed to sending all the data up the cloud first with all that noise?
Yeah, when you need to do this, you have to. Yeah. You have to. But on our cases, we have more whole data sending, and in some cases, a small CRC that we provide to just see, oh, the information is real or not, and we are doing jamming or something like this. Thank you.
You mentioned in your examples that you are putting a lot of data up to the cloud. Mm-hmm. How about using this data, especially in real time, to make some intelligent decisions? For example, you you have a machine that is doing something, you have the data up in the cloud, and you can analyze how the machine is working, and you can take some data decisions from the data and change some configurations on the machine.
Yeah, we think about it, but we don't have the algorithm so evoluted to do this. Because that we are storing the data first and then using, because if we do something wrong on the definition or this kind, we can use it again and run it again. That's our idea.
Latency in this part, when you, for example,
it's a problem.
It's a problem.
It's a big problem. When we talk about the for parking, for example, latency is not a big problem, but it's a problem. For example, when the car stays on the device, I need to build that guy. So I have some seconds to send him a message and say, oh, you are on the lot number 3, and you will pay $2 a minute, or you pay $10 an hour, for example. In this case, is a problem. On the hay, I can store the data for that ride on the device, and latency is not a problem for me. So, but we are in Brazil, so we have a lot of problems with latency, because when you talk using IoT Hub, for example, I have to set it here. And this is a problem to send the data here and to receive the message push back. And on these cases, I put a gateway and use a gateway inside our environment when we can, of course, and then I sync that to the cloud.
Doesn't necessarily mean that you need to send everything to the cloud. It you could send it to a
of course,
on-premises server.
You can also do all on the site, and then send only the result for the cloud. There's no problem. You don't have to always be connected. But some cases that we are working on, for example, the for parking, we have to be connected, because we need the connection. But I have another ones that, no problem. You can take the data all long day, and you have a small series of bytes, no problem, and you send on the end, or you send when it has the connection, or using Bluetooth or a gateway or something like this. Anyone?
The cost of cellular connectivity?
Sorry?
Question about the cost of cellular connectivity and how you're dealing with, are there lower cost ways to avoid those reoccurring subscription fees, or like a GSM chip?
Yeah.
What other technologies are you using to lower that cost?
Yeah, I like so much the idea of LoRa. We are trying to use, but in Brazil, we don't have we have a public problem, because it's not available in Brazil to use the high frequency of LoRa. And I have to do a project and approve it, but of course it's better for using instead the GSM or the another one. We don't have over there the LoRa. We still don't have over there the Sigfox, for example, that is cheapest one. We have an Embratel plan for machine to machine that is cheaper, but it's not so cheaper. And one thing that we try to use in some cases is the oldest telemetry idea of sending GPRS messages and then take it back. Any more?
Maybe a stupid question, but when you're collecting data from the devices, do you always design, structured database first, or do you basically start to collect unstructured data and then analyze it?
We try to structure the data, not a real. Sometimes we change it, by the way. It's on the middle of the project we have, because that we are big fans of NoSQL and these kinds, because on the middle, we decide to take another kind of data of or create another sensor inside the new devices, for example, or a new version of that. No more. So guys, thank you very much. And feel free to contact me if you have any questions. I can answer you. I will put my contacts on the screen.